This is worksheet for 2.5, and we're going to try and write things as compound inequalities in interval notation, union intersection, set notation, and on a number line. The first question is written as a compound inequality, and whenever you have an expression like this, which has all the terms written as sort of one sentence, the first step that I like to do is just break it up into two. So you know, first of all, that negative 2 is less than x, and x is less than negative 1. And if you remember from class, I said we use the expressions and or, and we put special symbols between them. And has an n in it, so it is intersection, and there's a symbol that looks like a giant N. Whenever you have something written like this, you know that it's going to have an and in it, or an intersection in it, because it's x is greater than negative 2 and x is less than negative 1. So we've already done our first one. We've done the union and intersection notation. The next thing we can do is convert that into number line. We know that we have to have negative 1 and negative 2 on it, so let's put those down there. Negative 1, negative 2, 0, negative 3. And for the left part of the equation over here, we know that x is going to be greater than negative 2. And since it's greater than, we're going to have a round parentheses, and it's greater than, so it goes this way. For the right half, we know x is less than negative 1, so we have a round parentheses, and it goes to the left. And we know that it's an intersection, so it's going to be the parts that overlap. If it were union, it would be the whole thing, but it's intersection, so it's just the parts that overlap. So to draw that on the number line, go from here to negative 1, and we color what's in the middle. Of course, once they have the number line, the interval notation is pretty easy to do too. We just copy the paren, whether it's square or a round, write the number that it starts at, the number that it ends at, and whether it's square or round on the other side. So we've already done 3 of them. Set notation starts with squiggly braces, x such that, and we already have the inside of it from the compound inequality. That's the easiest way to write it. If you already have the compound inequality, just copy it right in from here. So now we have our number line right here. We have our set notation. We have our interval notation. We have our union intersection. And we have our compound inequality. And we're done. Alright, for the second one, we're going to do it exactly the same way as we did the first one. This time it's 0 is less than or equal to x is less than or equal to 1. So the first thing we're going to do is break it into 2. So we know that 0 is less than or equal to x, and x is also less than 1. And since we know there's an and, we just put a symbol right in the middle. Now let's draw our number line at the bottom. And we have a 0 and a 1, so let's put 0 and a 1, 2, negative 1, negative 2, and we'll draw it using these colors again. So 0 is less than or equal to x. So this time we're going to have to use a square paren because it includes 0. and less than 1, so that's a round paren, going left. Then, when we combine these with the intersection, that means we just take the parts that are overlapping. So we have 0, and we have 1, and then we just color what's in between them. And once again, translating that into interval notation is pretty straightforward. We just take the left-hand side just the same way it is, write 0 where it starts, write the 1 where it stops, and we take the paren, the round side, just like we had on the number line. Next, we're going to do set notation, and again, we already have most of it done because the compound inequality is right up here. So we just say A equals X such that we stick our compound inequality in there. 0 is less than or equal to X is less than 1. So now we have our 5 ways. We have compound inequality, we have union and intersection, we have our set notation, we have our interval notation, and we have our number line. Alright, for our third one we have x is greater than negative infinity and x is less than or equal to negative 100. So this one is pretty far over on the number line, but we know that we have and in there. And from our previous slides we know that we can write that as a single compound inequality. And is exactly the same thing as intersection. So the first thing we can just do is x greater than negative infinity, intersection, x is less than 100. So we've done one notation. Now how would we combine these? The smallest number we have is negative infinity. We know x is greater than that, so we have the left side. Now what about the right side? X is less than negative 100. So if we can just put that in there, we have our compound inequality. Can we find an x that satisfies that? Yes, we can. Negative 200, negative 300, anything less than negative 100, in fact. So another way of writing this is just x is less than negative 100. In order to write this in interval notation, though, we're still going to need the negative infinity. We can never get to negative infinity, so you remember that we always use a round parentheses for infinities. Negative infinity is the smallest. Negative 100 is the highest. Oops, I forgot. Less than or equal to. And because it's less than or equal to, we have to use the square bracket. Well, now that makes our number line pretty easy as well. So we're going to draw our number line here at the bottom. We know we're going to need negative 100, negative 99, negative 101, negative 102. And from this side, the left side, we can see we go all the way to negative infinity. So we know we're going to go all the way here. The right side is less than or equal to negative 100. So we just take the interval notation here, use the same kind of square bracket, and we know it goes to negative infinity. Remember, I always like to color in the arrow if we go to infinity because that makes it really clear. If we stopped, it might look like I'm only going to negative 102.5 or something like that. But if I color in the arrow, that makes it very clear that we're going to infinity. So all we have left to write down is the set notation. And since we already have the compound inequality, that's pretty easy. A equals x such that we just take our compound inequality. We can write it with or without the negative infinity. So we can either write this whole thing, or we can just write this part of it. Because if x is less than or equal to negative 100, we know it continues on towards negative infinity. So we have set notation, interval notation, compound inequality, union intersection, and the number line. So this is the fourth problem, and here's one where I tried to trick you. The union symbol, with the big U there, if you remember, means we're combining two things together. So we can't write this as a single expression without something in the middle. There's no way to say, for example, how would we do this? Negative 2 is greater than x is greater than negative 2. No, that's not quite right, because that doesn't really make any sense. We can't do that. When you have a union like that, I think it's easiest to start with a number line. So let's draw it. Now I know x has to be less than negative 2. So let's make sure we have a negative 2. And so we have this round, because it doesn't say less than or equal to, and we know it's going to go left. And on the right side here we have x is greater than negative 2. So we start at negative 2 and we go this way. Now here's where it gets tricky. The questions we've done before are all intersection, which means the parts that overlap. So the intersection of this would be nothing. They never quite touch. But this is the union. This is everything. Remember, we're marrying these two lines together. But it never touches the number negative 2. So we still have to keep our parentheses. We still have to keep our parentheses. This goes all the way up to positive infinity, so we're going to color in that arrow. And this goes all the way down to negative infinity, so we're going to color in that arrow. And we keep our parens in the middle. Now this also makes it a little bit tricky for interval notation, because we don't really have minimums and maximums that we can just copy off the number line. We're going to have to write it exactly like the compound notation right up here. So what we're going to do is we're going to split it into two parts. So x, we know, is less than negative 2, and we also know that it has to be greater than negative infinity. That is always implied, right? As you can see down here, we colored in this arrow with red because we go all the way to negative infinity. The right-hand side is the same. It's x is greater than negative 2, but we also know that it is less than positive infinity. So I'm just going to write it the other way around. So x is greater than negative 2. I just flipped it around. I kept the opening side next to the x because we know the x is bigger, so it has the big side, and negative 2 has this little point. It's smaller. And x is less than infinity. So again, this is the trickiest kind of problem you're going to get. We got to write this in interval notation as never going to get to negative infinity, but we go all the way up to -2, but don't touch it, so we have a round paren, and it's that arrow unioned with -2, but we never touch there from the right-hand side, all the way up to infinity. So it takes a couple extra steps to get the union intersection in interval notation. There's no way to write this as a single interval notation because there are actually two intervals. You have -2 going up, and you have -2 going down, and they don't quite meet in the middle, so there are two different segments on this line. For set notation, we're just going to copy everything up here into our notation again. So A equals x such that x is less than -2. And here you can say union, or you can say or. Either way works. X is greater than -2. All right, we're back with the fifth problem. And this is set notation for a equals x such that x is between -infinity and 2. And so there's two ways to attack this. I like going with the number line usually and just trying to figure it out from there. So let's do that first. Let's just draw a number line. And we know we're going to have -infinity and 2. So let's draw 2. And we know it's going to be between -infinity. So we know it's going to go here. And we know it's going to go up to 2. But here's a word we haven't seen before, between. Between does not include. So if I'm between two walls, then I'm not in the wall. So we know that it's going to be less than 2 and not including 2. So we can put a round parenthesis on 2. And as we know, going from the number line to the interval notation is pretty easy. We just write down the same paren that we had. And we know 2 is the highest. We know -infinity is the lowest. And we know we can never reach it. So we put a round paren there. So then how do we go from the interval notation to a compound inequality? Well, let's write down what we know. We have -infinity, and we know x is greater than that. And, so what's the symbol for and? And has an N in it, like intersection. So let's draw a big N. We also know that x is less than 2. We've done our union intersection notation. Can we combine that into a single compound inequality? Well, we know that x is greater than -infinity, and we also know it's less than -2. So if we combine these into one, we can write it as x is greater than -infinity, and x is also less than 2. And just like that, we have all 5. Our number line, interval notation, union intersection, compound inequality, and set notation. So here we have another set notation with words in a sentence in it, but there's no and there's no or in it. So we're not going to have any compound inequality here, and we're not going to have any intersection or union. So how are we going to write this? Well, let's start with the number line again. We know we're going to have a 0 and a -1, -2. So if it's greater than 0, we know that we're going to have a round paren, and everything's going to go up here, all the way to positive infinity. So converting this into interval notation again, we have the lower bound, we know it's 0, and our upper bound is positive infinity, and we can never get there, so we know it's a round paren. But how would we write this as an inequality? Well, you guys are pretty familiar with that. We just say x is greater than 0. Now, can we do this with an infinity there? Well, we can kind of. If we want to say that 0 is less than x, which is also less than infinity, we can write it that way, but that's kind of overkill. Just writing it like this is usually the way you'll see it. If you want to be overkill with intersection union notation, we can convert this again. 0 is less than x, and x is less than infinity. Alright, so here we have our first number line problem. I like seeing things on the number line. It just makes sense to me. Because we know the easiest thing to do from a number line is translate it right into interval notation. We know we have a square bracket over here, right at -2, and we have a 1 at the top with a round parentheses. We've done one already. So how can we convert that into intersection or union? Well, we know it's an intersection because just like the other problems, we have a line in between two things, which means that it's greater than or equal to 2, greater than or equal to -2, and less than, because it's round, 1. So let's write that. X is greater than or equal to -2, and x is less than 1. And how do we write and? The N for intersection. Can we combine these into a single compound inequality? You bet we can. -2 is less than or equal to x, which is also less than 1. How would we write this in set notation? We just take this whole thing and drop it right in. A equals x such that -2 is less than or equal to x is less than 1. And there we have it. Set notation, compound inequality, intersection union, interval notation, and number line. So the first one that we're starting with interval notation, I've pre-colored into the two halves just to make it easier for us to see and to split it up into two parts. We can start with a number line again if we want. Because converting from the number line to interval notation and back and forth is pretty easy. We know that we're going to hit 4. So let's write 4, and with negative infinity. So let's write some more numbers here. So negative infinity, we're going to color that blue. We're going to go all the way up to 4. And we know we have a square bracket on 4. And that is all the information I have. So what does it mean, though? Well, let's write it out. We know that negative infinity is going to be less than x. And we also know that x is going to be less than or equal to 4. Is it going to be and or? Well, since it's between the two things, we know it's and. If it were or, if we put a union in there, x greater than negative infinity would take up all real numbers. So instead, it's going to be the intersection of everything that is less than 4 and everything that is greater than negative infinity. Can we write this as a single compound inequation? We can, because it's an intersection. So we have negative infinity is less than x is also less than or equal to 4. If you remember from a few slides back, we can even simplify this if we want. Because we know that everything on this line is greater than negative infinity, we can just simplify this as x is less than or equal to 4. And so I think we've met everything. We have our number line, we have our compound inequality, we have our interval notation, we have our set notation. Oh, we forgot our set notation. But luckily, we know that we can just take our compound inequality and put it in the set notation. So we're going to use what we did here and just put that in the set notation because these are the same thing. We just showed that these are the same thing. So A equals x such that x is less than or equal to 4. We could write it with the negative infinity inside if we wanted to. That would still be perfectly correct. But we don't have to, and that's shorter.